of the South African System Dynamics Chapter Seminar Series for 2022. We actually started this initiative to give more value to our registered students and beginners and people who are interested in learning about the dynamics. I've gotten quite a few emails asking about how you can join the chapter. Dr. Nalini will put a link, I think, in the chat box on how you can access the registration page and join the chapter. So our very first webinar was about generally applied system dynamics for beginners, where Dr. Nalini and Dr. Boeta literally just gave us the basics of modeling in system dynamics. So today we are looking more on qualitative modeling with systems archetypes. You know, there are two types of modelers. There are people who are just quantitative modelers who just go straight into the modeling process and they start doing the stops and flows. There are also people like myself, more specifically, who like to develop causal loops to visualize the model first before I start modeling. So system archetype will actually introduce us a little bit about what CLDs are about and what system archetypes are about. So our presenter for today is Dr. Rudolf Oestesen. He's a senior lecturer at the Graduate School of Technology at the University of Victoria, where he teaches systems engineering and systems thinking. Of late, his focus has been more on data science and AI, artificial intelligence for decision support, and situation awareness. He's a registered professional engineer with the ECSA and a certified system engineering professional with IGNOS. So today he will be taking, I think, the next hour and a half just to talk to us about qualitative modeling with systems archetypes. So please stay tuned and I'll hand over the floor now to Dr. Rudolf. Thank you very much.
Thank you, Jon. Just to confirm again, nothing has changed. You can still hear me clearly?
Yes, I
Okay.
can hear you.
Yes, I don't think I will keep you busy for an hour and a half, not anywhere close to that. I'd be surprised if I'll be speaking for half an hour, because I'm normally a quick speaker. I try to get these things over and done with as quickly as possible. But I think we can spend some time as maybe at the end to share some ideas around it. Of late, I have been starting to look at system archetypes, especially as part of my systems thinking course. I found them very useful to get the concepts across to the students to try and understand the underlying issues around systems thinking and how to get to starting to modeling the situations or the problems that they need to investigate. Okay, my quick presentation will consist of a short introduction, a few thoughts around systems thinking, so definitions of the different archetypes, and then you're going to look at the basic structure of archetypes. Wallström had a very nice paper, and I have the reference at the back of this presentation, around the basic or generic structure of the archetypes, and he defined basically 4 of them. I would rather spend today on getting those structures of the 4 of them through, and because they are the foundation for all the other archetypes that have been defined through the last couple of decades. I think there's currently about 10 or 12, but I've seen many papers where there are new ones being identified and named as the people do the modeling. And then at the end, I will go through a basic modeling process for systems thinking that can be found within system dynamics as well, and to show how and where your basic system archetypes can play a role to help you to model the problems. The sweet and short of systems thinking is to investigate the structure of complex systems to try and understand the behavior that you observe to try and get hold the deeper understanding. And these systems are normally in the form of problems, and they tend to be complex or wicked or messy, etc. And there are many tools that is being applied.
Having a physical illness, a protective factor could be having.
Okay. Somebody else just switch off that mic.
So feeding back again to that idea of
Thank you. There are many tools available to do this. There are the causal loop diagrams, cognitive maps, rich pictures, systemic grams, the soft systems methodology, and also system dynamics I see as one of the main tools in this whole arsenal of tools they can apply. And system archetypes is just one of them, and I feel that can play a big role. Systems thinking help you also to simplify the structure, to help you identify the causal relationships that you try and model, and to try and understand how you can apply a solution to this wicked problem, and to help you uncover the system behavior. Over the last couple of years, there has been a marked increase in the use of archetypes and system dynamics modeling specific, especially within the sustainability research field. So if you look at what is the definition of an archetype, archetypes originally come from the personalities and psychology type fields, and was defined by Carl Jung as something like an old watercourse along which the water of life has flowed for a time, digging a deep channel for itself. And the longer it has flowed, the deeper the channel, and the more likely that sooner or later the water will return. So in essence, it comes down to they are the standard things that's been etched out in life. There are certain behaviors within complex systems that tend to repeat themselves. So therefore, Sengi and Wolstenholme defined it for systems thinking specific as the formal and freestanding views to classify system structures responsible for the generic, which can be often counterintuitive behaviors of pattern that you can observe. So in essence, to summarize what the previous few pages the system archetype is a high-level picture that can be an abstraction or the high-level story or a fingerprint of what you observe of the recurring generic or systemic structures, which often consist of the combinations of feedback loops that form the underlying structure of the system that you want to investigate. They provide for you a theory of the system behavior to help you to try and understand the nature of the problem and to communicate the side effects of system changes to stakeholders, and also provide for you a foundation or a structure, a template to start modeling from, to look for what you want to model within the system. Wolstenholme has identified the genetic structure of an archetype as consisting of at the least two loops. The one is the intended consequence loop connected to the unintended consequence loop. Often the consequence in one part of a system, they lead to consequence in another part of a system that can be unintended, and that can be separated by a delay or a system boundary, where the system boundary can hide the consequences from the entity taking the action to achieve an outcome. There are two different ways to look at these archetypes. Can be either from a problem perspective or from a solution perspective, where you try and counter the bad behavior of the system. So to try and create a solution for the specific archetype, you must try to remove the system boundary that obscure the side effects. You must try and enable collaboration across the boundary, because these consequences might even be without outside your organization, where you don't have no control of it, and you often don't see it or know about it. You have to acknowledge that there is a delay and do things to try and counter the delay or remove it. So in the end, it will turn out you either have to break a link, add a link, or shorten a delay. So Wolstenholme has broken this up into 4 basic archetypes. Well, in essence, turns out to be different combinations of reinforcing and balancing loops within the intended and unintended consequence loops. And these archetypes focus on 2 aspects, either trying to achieve something or to control something, which might not always be possible. So the first one is called underachievement. This is where you have an intended activity to try and achieve something, but it fails to materialize. You have a reinforcing loop to achieve an outcome, but there is a system reaction that is a balancing loop that works against this, which is maybe from some sort of constraint sitting with outside the system. The balancing loop over time will increasingly counter this outcome that you want to achieve, especially because you have a delay present in it. And if the entity trying to achieve the outcome is not aware of this balancing outcome or the counterintuitive or the counter activity taking place here, you will actually only worsen the problem to try and achieve the outcome more vigorously. So for this archetype, the solution is said to be you need to detect the delayed reactions from across the system boundaries. You add a reinforcing loop from your intended action to try and reduce or alleviate your resource constraint, which will then form a reinforcing loop countering the balancing loop taking place here. The typical examples of this archetype are the limits to growth or limits to success, the growth and underinvestment, and the tragedy of the commons. As you can see, all of these archetypes have a combination of a balancing and a reinforcing loop working against each other. Some of them just have more of them. And for instance, in your tragedy of the commons, there are 2 of them that actually work against each other. Good. So this is the first one. So the second one consists of a balancing and a reinforcing loop that is called the out of control archetype. You try to control a problem through a balancing loop to try and control this problem with a controlling action and the problem that you want to control. However, this controlling action also influence or cause a system reaction through a reinforcing loop, which might also have a delay before you start observing what it's doing to your system. So your control might not be realized and your fundamental cause can be overlooked. Often this controlling action focuses on the symptoms or the short-term solutions. But however, that specific controlling action is then causing a unintended growth in another part of the system that's actually countering what you want to achieve. So the solution to that will be to get a focus on the problem, investigate it much deeper to actually identify what is a long-term fundamental solution. Also, what you can do is to get a link directly from the problem to what is a system reaction and get a solution link setting in there that is creating a balancing loop that will counter your reinforcing loop that's causing your problem. I think it's quite obvious that the examples of this out of control archetype are the general I think those are the more common archetypes for fixes that fail, shifting the burden, and also the accidental adversaries, where you have the balancing and the reinforcing loops working against each other. The third one is called the relative achievement. This is where you want to gain an achievement at the expense of another element within your system, where one element is called, let's call it A, try to achieve something irrespective of 4A. That forms a reinforcing loop. However, this relative outcome of A cause a negative effect in the other part of the loop for someone else. Let's call it for element B, which either is all two negative links, but still causing a reinforcing loop, also always with that delay present to make you not detect that immediately. So these two reinforcing loops compete with each other for the limited resource, and your resources keeps being allocated for the relative performance to try and encourage both A and B to have the best possible performance. However, for some reason, the one element gains an initial advantage over the other and then gains more and more resources while starving the other one. So the solution loop for this will be to implement some sort of regulatory action where you have a solution loop that's a balancing loop that try and limit the reinforcing loop to prevent it from running away. You have to recognize that is in the early ages as soon as possible, and you have this external regulation solution loop that's being implemented. And you need to have a relative target between the two that is more representative to make sure that there's a equitable transition to a new state to get a stable, good growth and competition going. Obviously, this is an example of the success to the successful. We have the two balancing loops competing against each other. The last one of the four is called the relative control, where you want to control something at the cost of another element in the system. The relative outcome you try to control, but that trigger a reaction in another part of the system. And that's compromising what you're trying to achieve. So in this, this is where you have the two balancing loops. So the solution to this is to have an absolute target or an absolute outcome defined, where you can have a reinforcing loop to balance out the balancing loop or counter the balancing loop. I think that's more accurate. For this, the examples are the escalation or drifting goals. So I'm not going to go into all the different archetypes that you can get, but I think when you start using archetypes as part of your modeling process, it's easier, more beneficial to start rather with these basic ones and then expand onwards. And there are many of these types of diagrams available that you can use to try and identify what the right archetype is for the model that you want to build or the problem that you want to solve. But I'm not going to go into that right now. So how and where do you use these system thinking archetypes? The first one is to use them as a lens that you can help you to describe the generic families of the problems. The different lenses of these different archetypes can help you to ask the right questions about the problem situation. Often you can look at one situation and you can try and map different archetypes onto it to see which one fits the best. And because the many archetypes can be present in a certain problem situation, depending what the perspective or the context is that you observe it from. Secondly, these archetypes also provide a structural pattern template, so that helps you to identify the known structures within the problems. If you have the variables and you have some relationships between them, you can, when you pick up the different balancing and reinforcing loops, you can then map that to specific behavior to be expected. And that's for the third one, where you can predict the common behavior using these archetypes. Once you have identified what pattern is present, which archetypes they normally represent, and that gives you a kickstart to do an intermediate abstraction of the different factors and relationships to help you also explain the phenomenon. And it leads to a dynamic theory as well, to help you identify the important processes that are existing within a system that you need to try and model and replicate or simulate when you do your modeling and simulation. So when you look at a basic systems thinking modeling process, and I think this can be relevant to the normal system dynamics modeling process, where you start the process off with capturing all the information available. you have to identify and describe the problem, try and get your time behavior over time graphs and to identify the variables present in them before you start doing the conceptual modeling. In the conceptual modeling, that's where you mostly look at causal loop diagrams to get the feedback structures explicit and to then lead to a system analysis where we will use some form of simulation using stock and flow diagrams, and in the end to your solution implementation where you have to communicate the outcomes of your modeling and to try and implement your new policies and use your tool and use your knowledge of understanding or learning that you have achieved. So if you start with the process to capture information, obviously you start with the stakeholder mental models and other information and data around the problem. From that initial data set or understanding you get, you can identify your generic system archetype that represent the common patterns that is immediately observable within the data or the behavior of over time that you can see. This then will feed into your identification and description of the problem, where your system archetype is a template and to guide you to try and find the unwanted behavior and fundamental problem causes. It also identifies some key problem situations and variables and how the variables can relate to each other. Then going on to identify specific archetype, as you learn more and you have more information and you can then maybe get more specific, you can get a specific system archetype where you can use that structure, the variables, underlying process, and also the typical behavior to help you with doing your specific conceptual modeling. To ensure that your causal loop diagram structure can relate back to your behavioral time graphs and also can help you to facilitate stakeholder interaction. The stakeholders like a good story. If you have a funky name for your archetype, it makes them excitable and it makes them thinking and talking about it a lot easier. So then you develop your dynamic hypothesis, typically with your causal loop diagrams, and you can describe the structure and behavior. And it helps you to link your causes and effects. Then when you have this good understanding, then you go and do your system analysis where you convert the hypothesis into your quantitative, or let's say it more quantitative stock and flow diagrams, and you can validate and simulate your outputs and use your model. And your system archetypes will also then be useful to identify the leverage points where you can break some of the vicious cycles and do your interventions within the system problem. And lastly, the system implementation where you designed your policies and you have to affect the mental models of your stakeholders. And the archetypes can help you to communicate changes with the stakeholders, and as they, with their funky names, provide a narrative format of how to achieve it. Yeah, and in short, this is how I see how I can use system archetypes for qualitative modeling. I must be honest, when I got the topic from Young with the qualitative modeling part in it, I was quite impressed, and it actually made me think a bit more about it. And I think there is some scope to do some further research and to try and really get a hold of how this will actually more and more can help you, especially with cooperative or collaborative modeling with all the different stakeholders, to try and get them involved, especially for people that are not as experienced in systems thinking and systems modeling as we are. Okay, and I think this is the point where we can start discussing it, and I'll be glad to answer some questions.